a couple years hence, we're in the year 2020 now, this information is changing and becoming updated all the time. And so if you happen upon this presentation in the future, I would encourage you to reach out to me and contact me, and I'd be more than happy to set you up with the most recent information. A wee little bit about me. I've always been interested in fish. Yes, that's me on the left. A little more hair on my head, but not on my face. I've always been fascinated with them, and I've had the great good luck to start working on lampreys here in Oregon since 2006. One of the things that it's kind of a speed bump with lampreys is that a lot of people really get kind of turned off by them, thinking they're very disgusting or that they will attack you, and that's just I like to dispel the myths on this. That the lampreys we have here are unlike the invasive sea lamprey in the Great Lakes. There's no evidence of our lampreys decimating fish populations. They've co-evolved with their prey species out here in Oregon. And if you see lampreys in your creek, that is a very good thing. They provide a number of ecosystem benefits. The Oregon Zoo back in 2019 created and has been curating a brand new exhibit on Pacific lamprey. And I just like to show this because it's a play on the cute things. You got red pandas, obviously they're cute. And the Oregon Zoo said, oh, and by the way, the cuteness is coming with lamprey too. So a little bit about lampreys. Here's a picture of a Pacific lamprey. There are about 40 to 45 species of lampreys worldwide, depending on which taxonomist you talk to or read. And they are very primitive fishes. They're eel-like, but they are not eels. And they don't have jaws. They have no bony elements in their skeleton. It's all cartilage and fat and muscle. And when they are fasting, for instance, like the example of this adult Pacific lamprey, when it returns to fresh water, it will actually shrink in size because they don't have those bony elements to their skeleton. Now, the other cool thing about lampreys, and there's many cool things, is that they started to appear in the fossil record about 400 million years ago, which is really incredible because that's older than dinosaurs, older than sturgeon. And yet, as a taxon, they've persisted through time. They've changed very little over this time, but they've survived 4 global mass extinctions that have wiped out many other animals. So that is really a sobering thought when you start to realize over the last 100, 150 years that their populations have been decreasing. They actually may even be older, but because they don't have bony elements, unlike dinosaurs and other animals, they won't fossilize as easily. Right here in Oregon, we have a whopping 10 species of lampreys, which is really cool. So about a quarter of the species of lampreys worldwide exist right here in Oregon, and most of that diversity is within the Klamath Basin, about 5 to 6 species. And I'll talk more about species here momentarily. But what I want to point out is that lamprey are important for many reasons. One of the reasons is that they are an ecosystem integrator. They're used by many different terrestrial and aquatic animals, fishes, seals, sea lions, birds. And probably the reason is because they don't have bony elements, number one. And number two, they have a caloric content that's 3 to 6 times higher than salmon. So they're like a bacon cheeseburger to predators, where salmon are more of a salad, if you will. The other reason lampreys are important, beyond being ecosystem integrators, is their importance to many different Native American tribes right here in the Pacific Northwest. Tribal members use them for a number of things: ceremony, culture, medicine, food. And lamprey, this is a picture of Pacific lamprey at Willamette Falls. It looks like a pile of kelp, but those are actual many hundred individual lamprey. They used to be very abundant in the late 1800s, early 1900s. But that's not happening anymore. We don't see those kind of abundance numbers. Their numbers have really decreased. And that is because of many different limiting factors and threats. such as hydropower or dams that obstruct upstream and downstream migrations, degraded physical habitat, dewatering events that can kill thousands of larvae that are burrowed in the sediment but can't otherwise escape, and water quality, like these pre-spawn mortalities at Willamette Falls when the temperatures will get really warm. Therefore, there have been conservation plans that have been created to come up with strategies to mitigate for these limiting factors and threats and turn around the situation to increase lamprey numbers. The first among these was the Tribal Pacific Lamprey Restoration Plan by the Columbia River Intertribal Fish Commission. It came out in 2011. The next one that came out in 2012 and has been growing ever since is the Pacific Lamprey Conservation Initiative, administered by the U.S. Fish and Wildlife Service, with about 30 or more signatories, including my agency, the Oregon Department of Fish and Wildlife, various tribes, and many other entities. And our very own Oregon Department of Fish and Wildlife Conservation Plan for Lampreys. So these three plans at the tribal, federal, and state levels are all supplementary to each other and all complement each other and all aim for restoring and conserving lampreys. These first two focus on Pacific lamprey. This plan focuses on 4 species of lampreys. So that, I just gave you kind of a table of contents of how I'm going to discuss things, and now I want to go into a wee bit more detail. I'll talk briefly again about the several species. I will cover the status of the 5 that have been assessed. They are all sensitive. I will talk about the biology, focusing on Pacific lamprey and its limiting factors. And again, I will talk a little bit more about those tribal, federal, and state management plans. To start off with the biology of the different lampreys here in Oregon, I want to show you a distribution map. So here's Oregon. The blue is the current distribution for Pacific lamprey, and the red is the historic. There's a correlation between the historic distribution and artificial obstructions or barriers. Another species is the Western River lamprey. Like the Pacific lamprey, they rear as larvae in fresh water, then they emigrate to the ocean where they parasitize various fishes and whales, and then they come back into fresh water to spawn and die. The Western River lamprey is smaller. We know much less about it. What we do know about it, it seems to have a shorter or more narrow distribution than Pacific lamprey. From below Bonneville Dam out into the Columbia River plume and south down towards Yaquina Bay. The Western Brook lamprey has a distribution that's intermediate to Western River lamprey and Pacific lamprey. This is a complete freshwater resident. It doesn't leave freshwater. And the Pacific Brook lamprey, which is very similar to the Western Brook lamprey. Again, entire life cycle spent in fresh water, and we know the least about it, but what we know suggests that they occur in the Willamette River Basin. Now here are those 4 species again, shown by relative size, Pacific lamprey being the biggest and most cosmopolitan of the 4 species. And these are the 4 species that we assessed in our conservation plan. The other species that occur in the Klamath either have their own plan, which I'll talk about briefly, or they don't have a plan. So for anadromous parasitic lamprey, again, Pacific lamprey, Western River lamprey, and the resident non-feeding ones, that's when they transform into adults, they don't feed, they just spawn and die. All of these lampreys die after spawning. Our assessment through Oregon Department of Fish and Wildlife is that these 4 species are on this sensitive species list. As such, that makes them Oregon Conservation Strategy species. Here is a 5th lamprey, the other one for which we have a conservation plan that came out in 2005, the world's smallest resident parasitic lamprey, the Miller Lake lamprey. 6 inches at max and often somewhat smaller. They are also on the sensitive species list. Back in early October, I think it was October 15th, there was an OPB special that myself and colleagues were on about the Miller Lake lamprey. If you're at all interested, I encourage you to go online and check it out. Now, given that we don't have lots of time, I need to focus on one species, and so I chose Pacific lamprey because of its importance to Native American tribes and its wide distribution in large body size. Here are the life stages for Pacific lamprey. Larvae, which we sometimes call eyelashes because they are literally as big as an eyelash when they're young of year. Here's an older larvae, about 3.5 inches. They start getting to about 4 inches. Based on the right physiological cues and environmental cues, they will transform from an eyeless, toothless, filter-feeding larvae into an eyed juvenile that's silvered up and has sharp teeth ready to parasitize fishes and whales in the ocean. And so you can sometimes see these in the fall, and they will be ready to go out during the fall, winter freshets, and it can take about a year for this transformation process from larvae to juvenile to occur. Here's a picture of a juvenile sucking onto the side of a 5-gallon bucket. And here's a picture of an adult. This one's about 19 inches long. And then when they spawn and die, they provide marine-derived nutrients. See all these caddisflies on this carcass. Here's a depiction of the life cycle. So as juveniles in the ocean, they parasitize fishes and whales for their best estimates are for anywhere from less than a year on up to 6 years. Then they return to fresh water for their spawning migrations. And when they spawn and die, and this can be anywhere from several weeks to over 2 years in fresh water, and they're not feeding that entire time. And then their fecundity is incredible. They can produce upwards of 200,000 eggs. Those eggs are fertilized in the nests, and they then, after about a month, will hatch and drift downstream and settle out in what my friends call frog water, which is, calm water that has soft, sandy sediment that they can burrow into like earthworms. They orient their mouths to the surface to filter feed on algae and microbes. And then again, they at some point in the future, it could be between 3 to 10 years, they will transform as juveniles to emigrate to the ocean and start the process anew. So I want to take you on a journey from a juvenile that's turning into an adult, migrating from the ocean into fresh water. But before we do that journey, we start in the ocean. Here is the sucker mouth of a Pacific lamprey that they use to attach to hosts. And please don't be scared by this. These things will not attack you. I don't care what you see on river monsters. And these teeth are made of keratin, just like the fingernails and toenails you have. And this is this rasping tongue that uses to create a hole. There's no strong evidence that they kill their prey. We've seen evidence of lots of different prey from colleagues that they produce holes in some of the prey but don't kill them. Here's some examples of parasitic wounds on various ocean fish, like hake and sole, mackerel, eelpout, lingcod, flounder, sablefish. Several of these are superficial wounds, some are a little bit deeper. Here's another picture from NOAA Fisheries. The Pacific lamprey on the bottom are probably only been in the ocean maybe a year, but they grow really fast to adult size. And then when they get the right cues, they'll migrate from the ocean back into streams. So now I want to take you on a journey across the riverscape. Here's my friend, Confederated Tribes of the Coos, Lower Umpqua, and Siuslaw Indians, elder Doc Slider. And he's playing his flute by Eel Creek on the coast, there by Lakeside, where we've done some research. And he often does this before we do our lamprey work there. So that's pretty cool. But I'm showing it to you here now because when these lamprey come back, traditionally, tribes used to harvest them on their way back. And this also includes areas like Willamette Falls, 40 feet high, and the chief primary source of tribal harvest along the West Coast, rivaled maybe only by the Klamath River mouth. So tribal members will wait in there, and they'll grab them wear cotton gloves so they don't lose grip, and they'll put them in gunny sacks and take them back and prepare them for their feasts and other uses. I had the privilege of knowing tribal elder Elmer Crow, who passed away a few years ago, and he has a number of notable quotables. And his main one I like is, "The lamprey is our elder. Without him, the circle of life is broken." Elmer and other tribal members have also said that if we want to recover salmon, we need to recover lamprey. So really, really pretty insightful comments. Now here's a picture I took when I was doing research at Willamette Falls. These are all Pacific lamprey. Look at the wide range in sizes. And actually the smallest one on the bottom and the biggest one on top are both males of the same stage of sexual maturation. So there's a wide variety of body sizes within Pacific lamprey. And now what I want to do is take you on a journey through the Willamette River, where I've done most of my research, including telemetry studies on where we've tagged over 400 Pacific lamprey and then tracked their habitat use. A key use in the lower river is the main stem. We'd find a number of lamprey there. The further upstream we got, where we can actually see structure, we would track these radio tagged lamprey into areas like rock revetments, which are used as riprap to armor the sides of the channel to prevent meandering, which the river would do. And the lamprey like to get into those crevices in those rock revetments. We think that's probably a good way to avoid predation by animals such as mink, river otter, white sturgeon, that kind of thing. And we knew that we were onto something because we found many in these areas, and then sometimes we would actually even have the privilege of seeing visually with our own eyes a lamprey in those areas. Boulders were another area we find a number of lamprey associated with while they're holding. And then at nighttime, that's when they start moving again. So they're very nocturnal in their upstream migrations. We also found a number associated with logs. So you can imagine that the recruitment of large woody debris to the river, like what Zach was talking about in the Nehalem, can be a good thing. It provides structure for these animals. And root wads as well. Now here's a depiction of the upper Willamette River between Albany, where I live, and Harrisburg. And what I want you to take away from this is, over the course of about 100 years, notice how this section of the river goes from very meandering and very complex to more and more and more simplistic. As its sinuosity, its channel braiding, and these other features become more simplistic. And the reason for this is because of the removal of large woody debris by people in the 1800s and 1900s to allow steamboat traffic, and also the armoring of the banks with the rock revetments I showed that would keep the river from meandering, and also inclusion of a number of impoundments in the Willamette. Now I want you to keep in mind these last couple of years in this series, 1932, 1995, becoming ever more straight. Now let's look at the harvest of Pacific lamprey in the same basin further down at Willamette Falls. I showed you this picture. They used to be very abundant. And that was in the early 1900s, but we, as an agency, didn't really start keeping track of harvest until the late 1940s. And the harvest was as much as over 500,000 fish. And so probably in 1932 and earlier, it could have been way more. And now, here's 1995 again, very straight, less complex, and look at the harvest, way lower. Now, correlation is not necessarily causation, but what I am trying to suggest here is that this decreased harvest may be a function of less rearing habitat and less pheromones from the larvae to attract adults. Now, we can't say this is black and white and this is how it is, because harvest is affected by other things like the amount of human effort. But nevertheless, to me, it's a compelling story. Now, these adults, when they come back, they will attract to the larval pheromones or chemical signatures that the larvae emit. So the larvae are in substrate, they emit the pheromones, and the adults will home to it. From a human perspective, this is kind of telling the adults, hey, this is a good place to rear your young, it's safe, others are rearing here. It's, however, not always necessary, because there's lots of examples of Pacific lamprey recolonizing areas that they had formerly been excluded from for decades. Now, here in the Marys River is my friend standing in a pool tailout, which is the transition area between a pool and a riffle, and that's the kind of area where we often find Pacific lamprey nests. And they are a circular pot-shaped nest. It happens during the spring when they spawn, and unlike salmon and steelhead, you can oftentimes approach the red and the female or male will not scare off. Here's a picture of two males at the top and a female at the bottom. These animals I reared in the laboratory after capturing them at Willamette Falls, and they shrunk considerably with those dorsal fins touching, whereas they weren't before, and they became sexually mature. So all that energy from the insides was being funneled towards producing eggs like this very large female here. Those are all eggs in there, 200,000 or so, or towards milt with the males. And here's a beautiful picture from Drift Creek Silettes showing Pacific lamprey under some structure in a nest, ready to spawn. Here's another. And now I want to show you a little bit of a video of spawning behavior in Clatskanie River in the Lower Columbia. So let me escape out of this and we'll show you just a few minutes of this because it's really pretty awesome. So, okay. Okay. In the interest of time, I'm going to leave it there. I want to point out that these are large ones are the Pacific lamprey spawning, and the little ones coming in are Western Brook lamprey opportunistically using that area to spawn. There's no evidence that they're hybridizing with Pacific lamprey, but rather they're using the same area opportunistically. And you saw those adults using their sucker mouths to move rocks and cobble out of the nest so they can spawn. And there was some spawning going on there. Very, very cool stuff. You can look this up on YouTube. This was posted by a colleague of mine, Derek Wiley.
Hello.
Okay, so
Can I ask a question?
sure.
Okay. I don't know if it's an appropriate time, but I'm kind of fascinated by the concept of, this cladistically ancient creature apparently playing a linchpin role in our estuarine and riverine systems, with respect to the salmonids, which are I guess evolutionarily several times advanced more than the lamprey. It would be like a P-51 Mustang versus a World War I biplane, but somehow these lamprey are relevant. Does that mean something, important?
I'm not sure I understand your question.
Well, you've
I will
got a
say,
very ancient species, playing an important biological role in the determination of a much more advanced salmonid species.
yeah, though I agree, and I'll show you some examples here shortly of how they provide ecosystem roles. Um, and I think, what you're saying about salmon being more advanced is technically correct. But I take a little bit of issue with the advanced thing there because it's all relative. Now, one could argue that lamprey, even though they're more primitive, which is certainly true, um, whatever they've done when they first arrived on the scene has been very successful for them.
Well, yeah, that's exactly what I'm talking about. Like they stumbled onto a body plan and a strategy very early on that continues to work probably out of relevance for who it was developed against. But it
Yeah,
continues
you could,
to work against, even, you know, animals that have evolved much later, in
right?
whatever arms race was going on. Whatever
Yeah,
arms
you could,
race there was, the early lamprey biplanes didn't get left behind. They're
right?
still slugging it out in the jet age.
Yeah, yeah. I hope they continue on into the future. But yeah, it's a good point. In the interest of time, I think I would like to keep going here so we can have time for more questions at the end. But yeah, that's a good point. One could say the same of sharks and sturgeons as well. Um,
Right,
so what
a paperclip. Some designs never go out of style.
Velcro? Yeah, that's a good point. Yeah, thank you for that. The picture I'm showing here shows different types of habitat. Don't worry about the type 1, 2, and 3. What I'm trying to show here is that across the life cycles, this quiescent river area of the river with soft sediment is the kind that larvae like, and you'll find them less frequently here and here. But these other types are what the adults use to spawn in. Here's another example of that type 1 larval heaven, if you will, that lampreys like. And here's an artist's depiction of lamprey, how they actually orient in the river bottom, burrowing into it like earthworms and filter feeding through the top. There's been research done on this to show that larval lamprey benefit stream ecosystems by aerating the substrate by virtue of their burrowing, which can increase the complexity of animals available on the stream substrate. So that's pretty darn cool. And here's some really young lamprey, maybe perhaps a year or so old, showing them with their mouths oriented towards the surface, filter feeding. And here's some research we did where we've done surveys to look for larval lamprey. We found them all in different habitat types, but the most prevalent catch per unit effort was in off-channel habitats. And I find this fascinating because if you take that piece of knowledge and think back to the main stem Willamette, when there was lots of breeding in channels, you have a lot of off-channel habitats. So that potentially, when lamprey were very abundant, there was potentially lots of rearing areas. Now here's a depiction between habitat use for Oregon coast coho salmon. Um, the blue shows the relative use. So they tend to use medium to small streams, and that's where a lot of restoration has focused. By contrast, Columbia River chum salmon are oriented more towards estuaries where there's much less habitat restoration. And then contrast that with Pacific lamprey that use large rivers and medium streams primarily. So when you look at habitat restoration, it's good to look across different animals. And some of these animals like chum and lamprey may not be benefiting from these small stream habitat restoration sites. One reason small stream habitat restoration sites are effective is that you've got fewer landowners and less worries when the large woody debris gets blown out in terms of it's going to go out and collide with a bridge or whatever. But it's good to keep these kind of things in mind. And now here's the ecosystem integration aspect of it. 41 species of predators have been documented to consume Pacific lamprey. And Pacific lamprey have been documented to parasitize 32 different species of prey. Now I get that why would people want to conserve a species that preys on other species that people use? But my comment on that is that ecology is very complex, and think of all these animals as nutrient sources for the lamprey that then takes those marine-derived nutrients and provides them to fresh water when it spawns and dies. Okay, so that
every prey that you're showing on that right graph is cladistically more modern than the lamprey.
Yeah. Well, the only thing that's not more modern than the lamprey is perhaps a hagfish, but they're closely related to lamprey.
So that's a good kill ratio, isn't it?
What's that?
That's a good kill ratio. If you're an ancient species and you're still preying on as many people are preying on you, then isn't that the ultimate judgment of whether or not you're a successful species?
I think you could make that argument. Okay, so limiting factors. Some of the main ones include passage barriers, like culverts, dams. And now I want to show you a brief video clip of an adult Pacific lamprey at Winchester Dam trying to navigate around a 90-degree corner. So it's going to go fast and then it's going to repeat in slow motion. So the way that adults move upstream is by burst and attach swimming. They cannot do sustained swimming at high speeds like salmon. So here we go. So the lesson here is that those sharp corners, when it goes to go around, that the water will blow it back and it's hard to pass. And so our advice for passage is to have rounded corners. And so it got to this point, then it had the same problem again. Other limiting factors include dewatering that can kill thousands of larval lamprey that can't otherwise escape, and low water quality, and habitat degradation, as I mentioned earlier. Don't think I mentioned it earlier, but another limiting factor is predation by non-native warm water species like smallmouth bass that have been shown anecdotally and experimentally to have the capacity to consume large numbers of larval lamprey. And I mentioned the tribal, the federal, and our state plans as the mitigation attempts to halt declines from limiting factors. And now here in the home stretch of my presentation, here's some examples of things we're doing. My agency, by virtue of my position and collaborations with other tribes and entities, have done lamprey identification workshops for education outreach. We have worked to help put on a lamprey short course through Portland State University. I think we'll be having another one in the future. We've done the same thing for River Restoration Northwest. And so those are ways that we're addressing some limiting factors. Other ways include working with people to put in lamprey passage structures. Now I'm showing an example from Mary Moser of the passage flume, one of the passage flumes at Bonneville Dam. We have other lamprey passage structures around the state that are smaller and more simple, but here's an example of adult Pacific lamprey going upstream on a flume. They just need a little bit of water to keep them wet, and then they'll do that burst and attach swimming to move upstream. Here's another example in the laboratory showing you that burst and attached swimming movement that they can also use to ascend some waterfalls. And so there we go. It's pretty cool stuff. We and others have worked to put together culvert retrofits to allow lamprey to pass. And we have been working with others to educate them on stream bed designs for culverts, which seem to be good for passing fishes in general. We're working with people to figure out what's the best way to restore habitat to benefit lampreys. And we are kind of in the start of understanding what works. It used to be whatever works for salmon works for lampreys, which what we would say. And now that's kind of changed to, yeah, well, that's true, but you need process-based. Now there's questions about stage 0 restoration, like 5 Mile Bell and South Fork Mackenzie, which is shown here. And so we are working with others to try to acquire more information to figure out what exactly benefits lampreys. I would say, in short, to go back to those complex meandering streams like the main stem willamette, I think that is the kind of thing that would benefit lampreys. We've also been working with other folks to create best management guidelines for native lampreys during in-water work. This is a free document that's available online. We've also, that's me on the left, inserting a radio tag into an adult lamprey to track their migration and passage of Leeburg Dam in the Mackenzie River. We're doing a similar thing in Eel Creek with folks there. We're involved in distribution surveys so we can better understand where they are distributed and where they aren't and why that is. And also looking at lamprey counts and numbers and trying to understand trends there. Passage barriers and prioritization for passage for upstream and downstream for lampreys. And species distribution modeling in relation to environmental factors across the landscape. The way I do my work is I'm one guy for an entire state, and I always say I can't get done what I need to do unless I'm collaborating with people. And I'm very happy to do that. So here's a picture of me with my friends and colleagues, Gary Vondero down in the Coos Umpqua district, Richard Litz from the Confederated Tribes of the Coos, Lower Umpqua, and Siuslaw, John Schaefer from the same tribe. And we've done quite a bit of work with them. And here's a picture of that same group and others that have helped. And some of the stuff we're finding with radio tag lamprey in that project is that they like to go under banks and root wads and under culverts. So if you're replacing a culvert, it's always good to be aware that you might need to be prepared to salvage adults. We've also been involved in a Leeburg Reservoir dewatering study that culminated in this paper that was published. And in closing, just want to say that I covered a lot of information. I don't expect you to remember all of it, but please feel free to contact me, reach out to me if you have further questions. I'm always happy to help. And in summary, we talked about there's several different species of lampreys. 10 in Oregon, 5 have been assessed. All 5 of those are sensitive. Biology is complex, as are limiting factors. And there's management and research plans at the tribal, federal, and state level. And with that, I'd be happy to take any questions.
Hey, Ben, we got one in the chat here from Haven.
Okay.
The question is, you said these fish are important to tribes. Where do tribes sit with restoration projects you are all working on, and how are they driving the work you are doing?
Oh, that's a good question. I would defer that to tribal members. It's hard to, you can't really talk about one example that applies to all tribes because they're all taking different strategies and tactics.
Very true.
Yeah, and I'm not aware of any tribe really working on restoration per se, although I know the Cow Creek Band of Umpqua Tribe of Indians is interested in restoration work in the Umpqua. Several of the Columbia River tribes have been working on translocating lamprey into the Snake River, Upper Snake River. Confederated Tribes of the Coos, Lower Umpqua, and Siuslaw is partnering with the 10 Mile Lakes Basin Partnership. Grand Ronde Tribe has been involved in some translocation work in the Willamette, helping us do some research. And that's what comes to mind. And I guess to answer that question in better detail, I would have to defer to tribal biologists and members.
For sure. I actually have a question. What do you know about sorry, let me back up. I got the impression that side channel habitat restoration on larger rivers is a very important piece of the puzzle for lamprey restoration. How do you know of any interactions between them and beaver dams, and do beaver ponds make for good lamprey habitat with all the silt they accumulate?
Boy, those are a series of really good questions. I think one could take away the conclusion that you did that maybe side channels off bigger rivers could be good areas to focus restoration. I'm not aware of research that has examined that exactly. I mean, I've showed some examples that led me to that conclusion. Beaver dams is a common question that often comes up. Similar answer to that, there hasn't been much work on that, although Damon Goodman of U.S. Fish and Wildlife Service and Stuart Reed have done some work in the Klamath and the Trinity Basin, I believe, that suggests that in some beaver ponds that they may be quite dense with larval lamprey.
Oh, neat. That's cool. I was hoping that was the answer. Did any folks have?
Can I ask a follow-up to that? Because I think, Zach, that, I don't know, it seems like we're thinking along the same lines. I'm fascinated by how such an ancient species is, dominating in such a selective and obviously difficult to, navigate ecosystem. The salmonids are some of the only ones that seem to have figured it out. But then you've got these other linchpins, like, beavers are some of the most odd mammals that ever came out of the mammal creator system. And to think that they might be allied with lampreys would be, the combination of that would be hugely interesting. It would seem. Like, how does this weirdo mammal and this jollish fish, from the Cambrian wind up as allies in some, ecosystem building venture?
Yeah, those are some deep philosophical questions, and I think it reminds me of that quote by John Muir. Is something along the lines of, the more we look, the more we see one thing's attached to everything else. And so I think qualitative judgments about dominating ecosystems, I'm not sure I would say that per se, but I certainly think they're very important.
Yeah, I think it shows that we have a lot more to learn.
Yeah, for sure.
Strange bedfellows.
Do folks have any other questions about lamprey for Ben? You can type them in the chat, or you can just unmute yourself and shout them out. If you have a question, chances are somebody else does too. So anything you got, feel free to put right out there. Why are they
that's
so
awesome.
cute?
Love it. I can't answer that, but I agree.
Well, thanks. It was fun.
You're very welcome.
Yeah, thank you so much. Oh, here we go. Do we have any specifics about lamprey on the Lower Nehalem, or in the Nehalem in general, other than lamprey presence?
Not to my knowledge.
Okay.
The lamprey world's still growing. There's been a ton of focus on the Columbia and its tributaries, and I suspect that this is going to change. It's been fascinating for me, Zach. These last couple of years, maybe the pandemic's helping this out, but the interest in lamprey has just become exponential. And so a lot of these questions you're asking about restoration, Hood River Watershed Council is asking some of the very same questions.
Yeah, I should connect with them and have a chat.
Yeah.
Yeah, it's one of those things where, as someone who is a restoration practitioner, my work is all heavily focused on, being very implementation oriented. And one of the constant worries is the possibility that I'm making a correction that's going to benefit one species at the expense of another. And so thinking about the different things that are in the system that I want to provide habitat for, it really shines a strong light on what I do and don't know already, and what we do and don't know in the literature as well, and in the knowledge base we have. So it's great to have you come and talk about this kind of stuff because yeah, it's fascinating to try and consider how do we also plan for lamprey while we're planning for other species in our restoration efforts.
Yeah, that's great. If you want, I'd be happy to email you some resources for further information, if that's helpful as well.
That sounds great. I would really
Okay.
appreciate that. We have a comment
Okay.
here in the chat. We have seen small lamprey in Coal Creek off of the North Fork of the Nehalem. What species might these be?
My guess is one of two, Western Brook lamprey or Pacific lamprey. If they're larvae, they could be more challenging to identify. At that point, we lamprey biologists focus on the pigmentation patterns on the tail. So we put them in like a little plexiglass viewing window and then look. Now, however, if you look at the fish and they've got eyes and they're small, it's very likely that they're Western Brook lamprey. The difference between the resident brook lamprey and the anadromous Pacific is that the resident brook lamprey's eye will be relatively small, his mouth will be relatively small, his teeth will look kind of not very sharp. The Pacific lamprey, because it's parasitic, its eyes will be really big, its mouth will be really big, it will be big, its teeth will be sharp.
What are the Western Brook lamprey then feed on if they're non-parasitic?
Right, they're awesome. They feed on the same stuff as all larval lamprey, but when they become adults, it's the weirdest thing. They don't feed at all. So
Oh wow!
they're a vehicle for procreation. Yeah, it's
So kind of
mind-boggling.
like some butterflies, they get all their energy in their larval stage and then have a couple glorious days of being adults.
Living the battery life.
It runs down. Well, I hope that answered, or at least provided some good speculation for that question. We got a thanks. I think we did good.
Good. You're very welcome.
Well, we're coming right up on the 8 o'clock hour here, which is our time. So unless there are any other questions for Ben, I will just say that, again, this has been a part of the speaker series with the Lower Nehalem Watershed Council. You can find us at lnwc.nehalem.org. And also you can follow us on Facebook. We have a Facebook page and everything. And we have upcoming talks. We'll be running talks all the way into May, I expect. And come check out one of our board meetings. Check out our speaker series. Come to the annual meeting and hear about all the great work we're doing. Ben, I don't know if there's any way for people to follow any of the work that you're up to that you want to direct people towards.
I think, Zach, I can't think of anything, but again, I'm happy to email you some resources, and yeah, please, anybody, feel free to contact me. If you don't have my contact info, Zach does, and I'm always happy to help.
Oh, tell us the number one reason we should monitor lampreys.
Because they are an integrator of ecosystems, all the way from recycling energy from the marine system to the detrital system. As larvae, they're filter feeding and recycling nutrients, and so they run the gamut of processing energy. That includes processing leaf litter that comes from trees that drop leaves into the water, and so they just do many things.
Great answer. Thank you.
You're welcome.
Fantastic. Well, with that, I am going to stop the recording. And thank you, everybody, for coming. I hope to see you all at future council events. Have a great evening.